Okay, welcome again to Psych 300. This is Dr. Tesler. We'll be doing our first Intro to Excel lecture today. So for this lecture, I'm starting now to use the sort of fancy equipment that they have in our library to record these lectures. Today's lecture is just going to be a voiceover type of thing. As we move through the semester and we start dealing with different topics, I'll be using some of the other fancy technology they have down here. But for today, you're just going to hear me. And so today is really designed to be an introduction to the program of Excel. You may have used Excel before, and if that's the case, you're going to find the stuff we talk about today to be probably pretty easy. But certainly don't worry if you haven't used Excel before, because we do kind of start at the beginning and build our way up. So without further ado, let's go ahead and get started. Here we go. Sorry, I'm learning to use this equipment. So if you haven't used Excel before, and you open a brand new Excel file, this is kind of what it will look like. I've saved this slide even though the actual format, the look of Excel may have changed slightly over the years, but I like this one because it has all the tabs pointed out. And also, you probably aren't going to see Comic Sans as the font on your Excel, but for some reason it isn't this slide. Otherwise, though, this should be a pretty close image of what you're going to see if you open a brand new Excel file. And what I want to do is point out some of the things about this file and this worksheet. So a file in Excel is going to consist of 1 through however many worksheets you need, and those worksheets are going to be laid out like a grid. At the very top of the screen, you're going to see our menu system. I believe it was Microsoft 2007, Office 2007, where they completely reformatted the menu system. Previously, it just had standard tabs like File, Edit, View, and so on. And then within each of those tabs, you had a list of functions that were dedicated to some specific thing you were trying to do. But when they reformatted it, they feature now this thing called the ribbon formatting. And the ribbon refers to that strip of functions that you see going across the top of the page. So we still have tabs like Home, Insert, Page Layout, etc. And then each of those tabs, we have our groups. Which are groups of functions that are all kind of similar or do some kind of similar thing. So you'll notice we have a font group, which is everything there is having to do with changing your font, and also you can add borders to your cells from there. You have the alignment group, which is where the text is aligned in your cell. And so on. It's pretty intuitive. I think even if you haven't used Excel before, you'll find that it's pretty user-friendly in that sense. Up in the top right-hand corner of the screen, you'll see the Quick Access toolbar. You're certainly welcome to customize that in any way that makes sense to you. You can add functions to that toolbar that you find yourself using frequently, like Save or something like that is going to be up there. What you're also going to find, though, there we go. What you're also going to find up there, though, is going to be the undo button, and we'll talk about that one later on, but the undo button is going to be good. It's a good thing for us to have. And so, like I was saying, in Excel, each file is going to consist of 1 through however many worksheets we need. This current version of Excel that we're using now can allow up to 16,284 columns and over 1 million rows of data. You might not be very impressed by that, but prior to 2004, Excel was only able to accommodate up to 256 columns, which meant you could only have 256 variables in your data set and only up through 65,536 rows. In other words, 65,000 cases. So from that, you can see where 16,000 columns and 1 million rows is quite an upgrade, and allows Excel to be used to run not just basic kind of stats analyses like we're going to do, but data mining projects as well. All of the columns in our worksheet are going to be headed with a letter or letters, so it's going to go from A to Z going across the columns. at which point it starts double scripting, so you have A, B, B, and so on, and it would do this sort of scripting all the way up through 16,284 combinations of letters. Each row in Excel is going to be designated with a number, 1 through, I guess, 1,048,576. And so combined, the column letter and the row number are going to create what we call a cell address. And so we're going to be working with cell addresses quite often in the whole time we're working in Excel. And so when we say cell address, what we mean is what is the combination of letter and number that refers to that specific cell's location. So on the previous screen, we saw that it's currently highlighted the very first cell there, and that's going to be cell A1, we can see, because it's the cell in column A and row number 1. The formula bar is going to be useful to us in the sense that it's going to display whatever formula has been entered into the cell that we're talking about. The formula bar is going to be this thing up at the top of the screen where it says FX. And so when we create formulas in Excel, which we're going to be doing a lot of, once you've created your formula in Excel and you hit enter, Excel is going to calculate the answer to whatever math problem that you gave it. And so in the cell itself, you'll see displayed just the answer to that formula. However, if you click on the cell that contains the formula, you'll see the formula displayed up in the formula bar. You can also see what formula is contained within your cell by double-clicking on the cell. And I'm going to show you examples of this in a minute. There's the formula bar in Excel. Notice that there's an equal sign up there before the 552. And one thing to remember in Excel is that every single formula that we ever create needs to begin with an equal sign. There was a time where when I was teaching this class, I used to have a keyboard up at the front, an additional keyboard that had a number representing each person's desk, each person's computer. And so I could click on anywhere, hit any of those keys, and look and see what people were doing. And so I used to do this a lot during exams in Excel to try to figure out, what people were struggling with, and so that I could modify it. And the biggest error that I would see people making when I would be spying on them and seeing what they were doing on their test was that they would create these perfectly accurate, perfect formulas to calculate some stat or another. And they would hit enter and nothing would happen. And they'd get frustrated. They'd look at it, they'd delete their formula, they'd retype their formula again, hit enter, and nothing would happen. And the thing that they would be missing ultimately was just that equal sign. So I try to emphasize the importance of starting every formula that we create with an equal sign. In creating our formulas, we're going to use the standard arithmetic operators that we would typically use on a calculator. The plus sign is going to do addition. The minus sign will do subtraction. Sorry guys, I'm just getting over a cough. The asterisk will do multiplication. The forward slash will do division. And the caret symbol, or the upward pointing arrow that is located on the number 6 key on your keyboard, will be used to do exponentiating. So if we need to square the contents of a cell, we'll type the cell address, that caret symbol, and the number 2, and that would square whatever is in that specific cell. When we're creating formulas in Excel, we can either create them using raw numbers, or what we will do most often is use cell addresses to create those formulas. So I wanted to show you exactly what I mean by this. All right, and so over here in cell A1, we can have Excel do basic math for us. And so maybe you aren't totally sure what 5 plus 7 would be. Why is it not letting me do that? Okay, sorry. Equals 5 plus 7. So imagine that's a real tough math problem for you. It's actually, my mental math is actually terrible. I have a PhD in something math related. You'd think I'd be like really good at math, but I can't add, subtract, multiply, divide in my mind at all. I always need a calculator. So maybe I'm thinking, I wonder what 5 plus 7 is, and I don't know. So I go into Excel and I type equals 5 plus 7, and I hit enter. You'll notice that Excel has done that problem for me, and it tells me that 5 plus 7 equals 12. Notice that what's displayed in that cell is just the number 12. However, when I click on that cell, notice in the formula bar, we can still see the formula that I used to get that calculation. If I double click on that cell, A1, you're going to see that it's going to display the formula again that I used to calculate that. So even though what's going to be displayed in our Excel file is going to be the answer or the thing that the solution to the problem that we gave Excel, Excel does not forget. It's going to remember the formula that we used to get that answer. So sometimes we'll use raw numbers. Most of the time, though, like I said, we're going to be using cell addresses to create formulas. So imagine instead that we have the number 7 stored in cell A1 and we have the number 5 stored in cell A2. What I could do there in cell A3 then is create a formula using cell addresses. So I could type equals A1. And notice when I typed equals A1, Excel recognized immediately that this A1 represented a cell address. It didn't know, I didn't have any suspicion that I was typing a text example here at all. It knew A1 refers to a cell address. And once I typed A1, it turned it blue, and it also drew a corresponding blue box around that cell, so I know which cell I'm referring to. And sometimes our formulas and our spreadsheets can get fairly complicated, so this is kind of a nice way of making sure that we're grabbing the cells that we think we are when we're creating a formula. In any case, I could put A1 plus A2. Then notice that Excel drew a red box around the A2 cell. So that it looks visually different. Excel actually has lots of colors that it has to use from. We'll see a few of those today. But it'll be able to at least separate visually the elements of your formula. So I can type equals enter, and when I do, Excel gets the same answer as before. 7 plus 5 turns out to be 12. If I click on that cell, notice up in the formula bar it says equals A1 plus A2. So Excel is indeed remembering the formula that we used or that we created to get that answer. If I double click on that cell, notice again that it's going to bring back up the formula that I created there. So it does remember what we've done, what formulas we've created in its mind. Okay. All right, so now you can go ahead and open the file that's labeled Excel 1 Data. I think it's Excel 1 Data Clear or something like that. Off Titanium, this is going to be our very first data set that we're going to look at. It's also going to be one of the only real data sets that you're going to see, meaning that I collected data on actual people for this data file. This data file is going to consist of data from my very first class that I ever taught in Psych 300. I originally intended to administer this survey that asks about age and months and gender and whatsoever, or what else. I intended to actually give this survey to every class that I taught and then have them be able to analyze their own data. It was a very lofty goal, and it was very unrealistic because I would have had to modify all of my slides every single time I teach this class, and I teach this class a lot. So what we have instead is going to be the data from my very first class. It is like I said, one of the only real data sets that you're going to see. I have one other one that you're going to see. The rest of the data sets that you're going to see from me are going to be fake. So you might think because I'm in statistics, because my PhD is in quant, that I would have lots and lots of data just sitting around, lots and lots of data sets, and I don't. I definitely have practically no real data. And that's because in quant, we simulate data. We create data. We create data sets to analyze using methodology and see how that methodology is performing. So what I've done is I've simulated a whole bunch of random data sets, and they're going to be pretty obviously fake for the most part. Like you'll see data sets about rainbow-colored hamsters and unicorns and things like that. And so there's not going to be any confusion as to whether that's real data or not. I think I only have 1 or 2 data files that you're going to see where it might very well be real data, but it's not. And I will always tell you what way that's going to be going there. So this is real data, though. This is my very first class that I taught at Cal State Fullerton back in 2010 when I taught 300 for the first time. And we can see that this data file contains some variables. So we've got subject number. That's going to be an arbitrary number that's assigned to represent each of the people in our data set so that we can keep track of their data. In fact, I'm going to go over here now and look at our data. And so what we have in here is we have this variable age and months, or subject. Right next to that, we have age and months. So what I did was I had them all calculate how many months they had been alive. Then we have gender. I have gender coded as 0, 1. 0 represents males, 1s represent females. And that's going to be true of every single data set that you ever see of mine, even if it's fake. And that's going to be the coding schema for gender. We're going to have another variable called miles from campus. That's going to be how many miles from campus, obviously, each of these people lived, how many hours per week they worked, what their preferred activity was. So here they were given a list of 5 activities: reading, computer, internet, recreational exercise, sports, and socializing, and they had to pick which of those 5 activities they preferred most. Then we have ext1. You'll see ext1 through ext5. And so what those are going to be scale items. So we've started to talk about constructs a little bit. And the idea behind measuring constructs is that we want to ask enough questions to measure all important aspects of a construct. But typically when we do that, we're not actually interested in any single question by itself. Usually our goal is to take all the items that we've asked to measure that construct and combine them in some way. So either calculate a sum score or something like that, so that we get one number that represents each person's level on that trait. So these are 5 questions, all that measured levels of extroversion. I don't even know what the original question text was. I don't think I have the original data anymore. But we don't even care. What we need to know about those things is that there are 5 questions, all intended to measure level of extroversion. All right, our first task in Excel is going to be to sort our data. So sorting is going to come in handy for us at several points during our dealings with Excel. And so I wanted to talk about how we do that. In Excel, in order to sort things, the first thing we're going to want to do is tell Excel exactly what to sort. So we're going to want to highlight the information that we want sorted. So we're going to click and drag all the way down from cell A1 through cell K26 to highlight our data before we go ahead and sort. If we didn't do that, if we didn't highlight the data first and we just went to the sort and filter command up in the top right hand corner, Excel would sort not just our data, but it would also try to bring in all of these other things that you see that fall below our data and sort that stuff too. And we do not want Excel to do that at all. We want Excel to just sort the data itself, leave the rest of it where it is. So in order to do that, you'll highlight your data. You're going to go to the sort and filter option. You're going to choose custom sort. And from there, we're going to notice that Excel has recognized that that top row, that very first row in our data set, consists of variable names. So Excel is going to recognize that those are not data points, those are variable names, and it's going to allow us to sort then by our variable name. So what we want to do is we want to click on that little drop-down menu where it says Sort By, and we want to choose age and months to sort by. It's going to sort on values as though there were anything else that it could use to sort by, and it's going to order these people in our sample from smallest to largest. So you'll notice that each row in this data set corresponds to an individual's score. So subject number 101 was 297 months old, was a female, lived 12 miles from campus, worked no hours per week, preferred socializing, and then we've got their scores on those 5 extroversion items. So what we want to do is order all of these people in our sample by age. So we want the youngest person first, all the way down to the oldest person in our sample. So once we sort by age and months, that's what we will have done. Notice now that our subject numbers do not begin at 101 and go through 125. They've been shuffled. Their order has been shuffled. And now instead of being ordered by subject number, we have people ordered by how old they were. The youngest person then being 227 months old, all the way down to the oldest person who was 450 months old. All right, second task in Excel. And also feel free at any point, so we're going to be going through some procedures here. Feel free to stop the lecture and complete the task, whatever it is. Normally when I'm teaching this class in person, I will stop my lecture and wait until everyone's caught up. Because we're recording this, though, I'm going to keep moving through. So if you find that we've reached a point where you've got to do some catching up, feel free to stop, catch up, and then we'll pick up from there. So our first task is going to be an entering data task. So notice that there's a variable in our data set called preferred activity. It's a categorical variable, so we've got some words in there that represent the categories of that variable or the activity that each person preferred. The problem with having data in text format like that is that we can't analyze it. So if we wanted to use preferred activity as our grouping variable in an ANOVA and we wanted to compare the readers to the recreational exercisers or something like that, we couldn't use that variable in its current state. What we would have to do is recode that variable. In other words, we'd need to assign numbers to represent each category on that variable. And so what we want to do there is we want to reassign or create a new variable, a recoded version of preferred activity, and assign numbers to represent those categories. Now, the first thing we need to do in order to accomplish this is insert a new column next to preferred activity. Effectively, what we want to do is create some space in our Excel sheet for that variable, that new variable to go in. And what we want to do is we want to put our new recoded version of preferred activity where ext1 is right now. So we want our new variable to be right there. And what we want to do is create a blank space here and move everything else over to the right. To do that, what we're going to do is we're going to highlight the area where we want to put our new variable. So we're just going to highlight the scores on ext1. Notice that I didn't just click on the G to highlight the entire column all the way down into infinity there. And the reason I don't do that is because if I do that and I insert blank cells, it's going to mess up my tables down below. So I just want to highlight the data itself. Then you can either right-click and select Insert, or you can select the Insert command from the Cells group up in the top right-hand corner. So I'm going to right-click, I'm going to choose Insert, and then Excel is going to make a guess. Excel is going to make a lot of guesses as we go to work through this program. And it's going to, most of the time, guess correctly. Excel is actually very good at guessing, at reading your mind and figuring out exactly what you meant for it to do. But it's going to ask you most of the times if it's right about what we think we want to do. So right now, by default, it's going to guess that we want to shift cells right. And what that means is once we insert the blank cells into that column, where do we want the rest of this stuff to go? We want it shifted over to the right. So in this case, it's guessed correctly. The other option would be to shift it down, move ext1 down in our spreadsheet. That's certainly not what we want to do. So in this case, Excel has guessed correctly. We can then hit OK. And notice that now, where ext1 was previously, we've got a blank column where we're going to put preferred activity recoded. So you can name this variable whatever you want. I'm going to call mine prefactrc. When I'm creating data sets, and I've recoded some variable in my data set, I usually create the variable name followed by an underscore and RC so that I know that that's the recoded version of my variable and not the original version. It's just sort of a note to yourself, in other words. And so now that we've got that variable labeled, we've created a variable name for it, what we want to do is assign a category for each of these categories of preferred activity. So assign a number to represent that category. We want to do that according to this schema here. So what I'm going to do is I'm going to go ahead and do that real quick for you guys. So socializing gets a 5, recreational exercising gets a 3, sports is a 4, 5, 3, 4, 5, and so on. So you want to do this on your machine as well. And like I said, if I get through this task and you are still not done, feel free to go ahead and pause this. And once I get done, I'm going to put that coding schema back up so that you can see it. So recreational exercise is a 3, 5, 1. Yes, I had to check my own lecture. All right. 4, got a 2 there, 4, 3. All right, so that's called recoding. When we get to SPSS, there's going to be a function in SPSS that's an automatic function for recode that we're going to just define the parameters of and let SPSS do it rather than doing it by hand like we just did. We could technically do that using an if statement in Excel, but it would take longer to create that if statement than would, in this case, to do it by hand. I mean, if you had, say, 500 cases that you needed to recode, it would be worth the trouble of creating that if statement. But for our purposes, we were just really trying to practice at entering data, and that's why we did it by hand. So here's the coding schema. Again, if you aren't quite done yet or you need a refresher here, I'm kind of leaving it up here for a second. Like I said, if you need more time for this, it's a good time to pause and fill in your column with the recoded version of that variable. Okay. Now you guys get to create your first formula. My classes are usually incredibly excited about this. Really, I see lots of smiles and cheers. Not really, just kidding. But this is going to be our first formula of many that we're going to create. So you'll notice that we have a variable in our data set called age in months. And that's kind of a weird way of thinking about age, right? So if you go up to someone, you say, how old are you? And they tell you that they're 450 months old. Not only are you going to be a little bit weirded out because it's kind of a strange way to report how old you are, but it's going to require you to do some quick mental math, take that 450 divided by 12 and figure out how old that person is. And if you're me and your mental math is awful, that's a task you're not going to even want to do. You're not going to care. So the way we usually are typically used to thinking about age is by measuring how old someone is in terms of how many years they've been alive. So what we want to do in Excel is create a formula that's going to take each person's age in months and convert it to age in years by taking that number and dividing by 12. All right. So first step here, though, is going to be to create the space for our new variable to go in. And where we want this variable to be is right where gender currently is. So we're going to do the same thing that we did before for preferred activity. We're going to highlight the values on gender because that's where we want to put blank cells. We're going to right click. We're going to choose Insert. And we're going to shift all those cells over to the right. That's going to leave us with a blank column in which we can put age in years. And now in C1 is going to be where we're going to create our very first formula. All right, so like I said before, every formula in Excel needs to start with an equal sign. And then what we want to do is we want to take the first person in this sample's age in months, which is going to be located in cell B2. And we want to divide that number by 12 to convert that age in months to age in years. Once you've got that formula entered, you can hit enter. And Excel will tell us that this person's age was 18.9. Now you might be thinking, oh, wow, that's pretty young, right? This is an upper division class. The only people in here are supposed to be psych majors who've declared psych as their major, and 300 is the first class you take. So you've got to be at least a junior. And so how did I end up with an 18-year-old in my class? Maybe they were a prodigy. Maybe they skipped out of high school early and found themselves over to Cal State Fullerton. But really, more likely, it's that I didn't use to check prereqs. You'll notice that not only did I not check them for you guys, you didn't get my intro lecture, and so I didn't even talk about how important it is, that prereq. But there was a time where not only did I not talk about it, I didn't really check. And so I ended up with an 18-year-old in this class. And so now what we want to do is we want to execute that same formula or apply that same formula to each person's age in months in this sample. To do that, what we're going to do is we're going to copy our formula. And as it turns out in Excel, if you use default copy, meaning hit Control and C at the same time, or you right click and you pick copy, or you find the copy option from the menu system up here under the clipboard group, you'll notice it also says copy. There's always 6 ways to skin a cat in Excel. So if you have a preferred way of doing any of these things and you're a seasoned Excel user, you've done this many, many times, feel free to use your own way of copying or pasting or any other function that we apply. I tend to use a lot of keyboard shortcuts because I work on a laptop most of the time. And so mostly I would not even right click. I would just hit Control C to copy, but it's up to you. I'll try to do the right clicking because it's a bit more visual here. So I would copy that cell. When I copy a cell in Excel, what it's copying, if there's a formula in that cell, it's actually copying the formula, not the number 18.91. You can tell, though, if you've successfully copied something in Excel because the border of that cell is going to flash, kind of like a Vegas sign there. And so it knows that I've copied that formula. What I can then do is go to the cell right below it, hit right-click, paste, Control-V, or you can find paste from the clipboard group up at the top left-hand corner of the screen. And so when I did that, notice that Excel did not copy and paste the number 18.9. It copied and pasted the formula. Not only did it copy and paste the formula, it correctly guessed that we wanted that formula to increment. So up here, we created that formula using the cell address B2 because we wanted to take that 227 and divide it. When I copied and pasted that formula, Excel correctly guessed that I wanted to increment down from B2 to B3. Excel is a pretty good guesser. Like I said, in this way, we just always want to make sure and check our formulas and make sure that Excel grabbed the correct cell. So We could technically copy and paste one at a time here to get the rest of the cells in this column, or we can copy that formula once. We can highlight the rest of the cells in this column, and we can right-click and paste that formula into all of those cells. And what that will do is give us each person's age in years in this sample. And so now we can see that our age range here goes from 18.9 all the way up through 37.5. Now, if you're a seasoned Excel user, you've been using Excel for a very long time, you may be thinking to yourself, oh, well, why didn't she just use that little green square in the bottom left-hand or bottom right-hand corner of that cell? Because that little green square cuts that process in two. It's one step rather than having to separately copy and paste. That little green square allows us to copy and paste in one step. I'll show you what that means. So if I click on that green square and I drag it down, Excel in one step is going to copy and paste those values. Now the reason that I don't teach it that way is not because I don't like that method, because I think it's fine. But if you are a new user to Excel, if you haven't used Excel very much, and you try to use that green square, the odds are you're going to come up against a big problem really, really quick. So maybe you accidentally drag over to the right one cell. Look what happens. So you can, as you can imagine, if you accidentally screw something up in Excel, I try to undo it and everything goes crazy. I've seen train wrecks created in Excel files by just people trying to use that little green square, which is the reason that I don't teach that method. However, if you try to go ahead and use it anyway, and you screw up your Excel file in a major way, like I am on the road to doing here, your saving grace in Excel is going to be that undo button. So we can hit undo, put that back, undo, put that back. I can even undo that copying and pasting that I did and put us back at square one here. So if you do find that you've made a train wreck out of your Excel file, undo is going to be your best friend. You can typically undo all the way back to where you were. If you find that you run out of undos and it's still not fixed, more than likely your only option is going to be to close that file and start over and just try to work from the beginning again. So try to be careful. Like I said, if you're a new Excel user, ignore the fact that that green square is even there and do a two-step process where you first right-click copy to copy that cell and then paste it into the remaining cells in the column that we're dealing with. Okay. So there's our age in years variable. We've created a new variable using a formula. Second formula that we're going to use now. So you remember I showed you that we had 5 variables in our data set labeled ext1 through ext5, and those are items from a scale that's intended to measure each person's level of extroversion. So now what we want to do is to create a sum score for those 5 extroversion items, because typically if we've administered a bunch of items that are trying to measure a construct, what we want to do is combine the information across those items so that we get one number that represents each person's level of that trait, of that construct. And so in this case, what we want to get is one number that tells us about the extroversion level of each person in our sample. So if you scroll to the end of our data file, we'll see ext1 through ext5. And so when we were in the survey construction lecture, I talked about how our goal in measurement, our main goal in measurement, is to be able to rank order all of the people in our sample from lowest to highest on some trait, some construct that we're trying to measure. And we want to do that in the most accurate way we possibly can. If we were only to use one of these extroversion items, notice that each of these extroversion items is rated on a 5-point Likert scale. So we could technically rank people on this one extroversion item using the numbers 1 through 5. The problem is that we wouldn't be able to differentiate between anybody who had a 5. So all of the 5s would look the same, all of the 4s would look the same, and so on. By combining all 5 of these items into one sum score, we actually are able to do a much better job at ranking people from lowest to highest on extroversion. So in the end column now, we're going to want to create ext sum. That's going to be our sum score variable for these 5 extroversion items. If it bothers you that there's no border on that sum cell, so notice that our other variable names all have bottom borders on their cells, denoting that they are variable names, you can add a border to this cell by selecting the cell, You're going to want to then go up in the fonts group up in the top left-hand corner of the screen and find the little icon that looks like a window with a little windowsill below it. That's going to be the border function. If you click on the arrow right next to that, you'll see the various options that we have available for kinds of borders that we can make. By default, if you just click the button, just click on the icon, it's going to put a bottom border on the cell, which coincidentally is exactly what we need. So if I click on that cell, or if I click on that little icon, that picture of a window, notice now that we have a line underneath the word EXTSUM. So it's a real variable now. So what we want to do in EXTSUM is we want to create a sum score. So we want to take the values that each person has for EXT1 through EXT5, and we want to add them together. I'm going to show you 3 different ways that we can do this. All of them are going to get you the same answer. However, some of them, as you're going to notice, are a lot faster, a lot less time consuming than others. The very first way, though, is my favorite only because it is colorful, not because it saves you any time. But what I could do is I could add together the values in each of those cells that I am intending to add together, beginning with I2. So I could type equals I2 plus J2 plus K2 plus L2 plus M2. And notice how pretty our Excel file is getting here. So we've got 5 different colors that it's using. And what it would do is it would add up the value in each of those 5 cells. If I hit enter, I see that the sum of those 5 numbers is 21, and that's that first person's score on our sum score on extroversion. So that's perfectly fine and not that time consuming if you've only got 5 values that you're adding together. But imagine we had 25 values. If that was the case, you're definitely not going to want to go through the process of typing out each individual cell address. You're going to want a shortcut of some kind. And so that's what I'm going to show you next. So another way that we can do this same thing is going to involve using a function in Excel. In this case, it's the sum function. We're going to use some of the other functions here in a little bit. But a sum function in Excel is going to be used when we want to sum across a cell range. And so what we need to do to use this function is we need to type equals sum, and then we open parentheses. And within those parentheses, we're going to want to define the cell range. Defining a cell range in Excel means telling Excel what the first and last cell address in that range is. So in this case, our first cell address is going to be I2. We're going to separate our first and last cell addresses here using a colon symbol. Note that's not a semicolon, but a colon. So we type equals sum, open parentheses, I2, and then the very last cell in this range is going to be M2. Notice when I typed M2, Excel is correctly noting that I want to sum across that entire range from I2 to M2, and it draws a big blue, not very colorful though, box around those 5 cells. We close our parentheses, we hit enter, and we still see that the sum of those 5 values is 21. So that's a little bit quicker. The fastest way, though, and the one you're probably going to want to go with most often, is going to begin with that same equals sum function. We're still going to open parentheses, but instead of typing our cell address range, we're just going to click and drag to highlight the cell range that we intend to use in our formula. So notice when I did that, Excel's going to auto-populate my formula with those cell addresses. I hit enter, I see that the answer is still 21, regardless of which method we use. So whichever one is your favorite one, you can keep using it. There's no right or wrong way to do that as long as you get the right answer. What we'd want to do now is we want to copy that formula that we just created and then apply it to the rest of the people in our sample. So we'd want to highlight the rest of the cells in that column and then right-click and paste. And now you'll notice that we've got values in this column ranging from 9 all the way up through 24. So we've got quite a bigger range than we had with any of these individual items. And we can do a much better job now at ranking people from least to most extroverted. And that's really our goal, like I said in measurement, is to rank order people from lowest to highest. All right, talked about that. I talked about defining a cell range, but this slide is here for your reference if at any point you need a refresher. All right, let's use some of the other functions that Excel has to offer. I really need to rename this slide because not only the first three of these are actually centrality measures, the other three are dispersion measures. So you probably heard these terms before, mean, median, mode, and so on. You probably learned about them in Intro Stat, which is a prereq for this class, so hopefully you took it. The mean tends to be the average score. The mean is the average score on some variable. The median is the middle score, meaning that if we rank ordered all of the scores from lowest to highest, the median would be the one smack in the middle of that list. The mode is the most commonly observed value for a variable, so the value that appears the most. The min is the lowest, obviously the max is the highest. And then we have the standard deviation. And one of the things I enjoy doing in my classes is asking people to define standard deviation and then getting to hear the crickets in the room as no one has a solid answer for that. Because more than likely when you took Intro Stat, you probably did learn to calculate a standard deviation. You may even remember the textbook definition of standard deviation being the average deviation of a given score from the mean, but you probably don't really know why we care about this number at all. We're going to get into why it's useful in a few weeks here, but for now we're just going to use these functions in Excel to calculate standard deviation. And if you remember calculating it by hand, you're probably pretty excited that we have a shortcut for that in Excel. So what we want to do now is we want to calculate the mean, the median, the mode, the min, the max, and the standard deviation for all of the variables in our data set. So I have slides in my PowerPoints that are sort of references for you. So a lot of times I go in lecture and I don't even go off the PowerPoints. We're in SPSS or we're in Excel. But I include the information that I'm talking about in case you need to come back to it. So what we want to do first is we want to calculate the mean for the very first variable in our data set, this age and months variable. And if you notice, if you scroll down to below, right below where the data ends, you'll notice we've got a spot for the mean of that variable. In Excel, the function that we're going to use for the mean is not the word mean, but rather the word average. It's the only one that's weird like that here. And what we want to do is calculate the average age in months. So we want to define now a cell range, beginning with the first cell for this variable, all the way up through the last cell for this variable, which ends up being B26. Close our parentheses, hit enter, and we see that the average age in months for people in this sample was 291.32. We'd want to then go ahead and go through and calculate the rest of these statistics for age in months using functions, and here are the functions that you need to use for that. So for the mean, it's equals average. For the median, it's equals median. For the mode, it's equals mode. For the maximum, it's equals max. For the min, equals min. And then standard deviation is just going to be equals STDEV. So go ahead and do that for age and months. I'm going to go ahead and do that in my file. So again, if you need to pause, now's a good time to do that. So equals standard deviation for B2 through B26. Whoopsie. B26 equals median, which is just the function for median, B2 through B26, equals mode is how we get the mode, B2 through B26. Minimum is equals min, B2 through B26. And then max is equals max, B2 through B26. So there we've gone and calculated those 6 statistics here, mean, standard deviation, median, mode, min, and max, for our variable age in months. What we want to do now is we want to calculate those same 6 things for the rest of our variables in our data set. What we don't want to do, certainly, is go one at a time and type those formulas out for each of these cells. What we would rather do is take a shortcut. And so the shortcut that we're going to take is going to involve copying these formulas and then pasting them into all these blank cells. We can copy all of these formulas in one step, in fact. So highlight all 6 of those things we just calculated. You'll hit right click and you'll hit copy to copy them. Then we're just going to highlight the area in which we want to paste those formulas, and Excel is going to do the rest for us. So we're going to highlight the space beginning in cell C27 and ending in cell N32. So we're going to draw a box around all of that. Then we're going to right click, we're going to paste, and we're going to see that Excel has done a lot of work for us right there. What this also does for us is it gives us a good opportunity to point out what an error message in Excel is going to look like. So Excel tried to execute that formula for all of the variables in our data set. However, we have that one variable that has text as the value labels, or the variable data points rather. We have that preferred activity variable where we have words representing their category choice. And Excel has gone to try to calculate the average word, and it got upset. Right? So the way that we know Excel is upset with us is it gives us this error message. And these error messages are going to all start with a hashtag, or I call it a pound sign, but you guys probably call it a hashtag. It's going to start with a hashtag, and then it's going to yell at you, right? So we know that when text is in all caps, that constitutes shouting. And so what Excel is doing is saying, hey, over here, look over here, you made an error. And it's even ending it with an exclamation point. So it's actually kind of yelling at you and saying, hey, look, you screwed up right over here. And maybe you didn't, right? So maybe we knew already that we can't get the average of a set of words. It doesn't even make any sense. So we know that Excel saw this as a problem where it was trying to divide by 0, and it ran into a problem. Over here it said, I don't even know what numbers you mean, and here it just said not applicable. You can't calculate the mode of a set of words. And so if we know that we haven't actually made an error here, it's not our formula that's the problem, it's the conceptual part, we can go ahead and ignore Excel's error messages. But that is indeed what they're going to look like. Those are major error messages. Sometimes, another thing that you'll see a lot of times, and we saw this with our ext sum variable, is that you'll see a little green triangle up in the top left-hand corner of the cell. And if you click on the little caution sign, it'll tell you what it thinks has gone wrong. In this case, that little green triangle is highlighting the fact that this formula omits adjacent cells. So what it's saying is, you only summed these 5 columns here. Did you really mean to sum all the columns? And so it's just noticing that you omitted that. So it's not necessarily an error so much as it's Excel just trying to let you know that you might have made an error. So it's just calling your attention to it. You can ignore that error, and you'll notice that little green triangle goes away. But it's not going to hurt anything to leave it in there. It's fine. It's just something that Excel does to get your attention. So now, back to this. So the next thing that we want to do here is we want to populate this table. So if you click on sheet 2, you'll notice that we have a little table that we need to fill in here. We want to put the mean, standard deviation, median, mode, min, and max for all 5 of these variables: age in months, age in years, miles from campus, hours worked per week, and extroversion score. We want to enter those values in this table of descriptive statistics. And so in order to do that, what we want to do is definitely not type these values in one by one. So go back over here, grab 291.32, type it in over here, right? We want to take a shortcut for sure. And that is going to involve using the transpose function. And the transpose function is going to allow us to take this array of numbers that's currently arranged in a column and flip it so that it goes across this row. That's called transpose. However, we can't do it yet, because if we try, don't do this certainly, but if we try to just copy those values, we go over to here and we try to transpose them, and here transpose is going to be under the paste option, it's going to be the 4th clipboard, and it looks like it has blocks on it. If we try to do that, Excel is going to yell "ref" at us loudly. And what it's saying is that it tried to execute that formula, tried to apply that formula, but the cell references don't make any sense. The cell address references don't make any sense. And that's all it's trying to tell us here. So what we want to do instead is we want to copy not the formulas, which is what it tried to do. We want to copy those values. So what we have to do in order to do that is get rid of those formulas. To get rid of the formulas, you're going to highlight those cells where those formulas exist. You're going to copy them, and then you're going to paste values. So you're going to not do anything else. You're going to right-click again, and you're going to choose the second clipboard over. That's the paste values clipboard. If you click on that, notice that now when I click on this cell that contains the mean for age and months, and I look up in the formula bar, I see that the formula is no longer there. It's just the value that's left over. So our formulas are actually gone. And that's fine, because what we want is the value. So now I can highlight those 6 cells. I can hit copy. I can go over here to sheet 2, click on this cell right here, right click, find that fourth clipboard with the blocks on it, hit transpose, and that's going to convert that column of scores to a row and put them where they go. So we can go ahead and do that for the other 4 variables that we're interested in, being age and years, miles from campus, hours worked per week, and extroversion score. The next column over from age and months is age and years, so I'm going to copy that set of formulas. I'm going to paste the values to get rid of the formulas. Then I can copy that, go to sheet 2. For age and years, click on that cell right under the mean for age and years, right-click, transpose. Do the same thing for miles from campus. Notice that miles from campus and hours worked per week are right next to each other. So if we wanted to shortcut that even more, we can highlight both at once, copy, right-click again, paste values to get rid of the formulas, copy those values now. So copy a second time rather. Come over here to sheet 2, click on this cell right there, choose the transpose function, and it's actually going to do 2 variables at once for us. The last one we need is extroversion score, which is all the way at the end of our data set. We'll highlight those 6 things for extroversion score, copy them, paste the values, copy them again, come over here to sheet 2, click on that cell, right-click, and then transpose. At that point, we'd want to clean this table up, right? So right now, in doing that last transpose, we got rid of the border along the bottom of our table. We want that border to be there. So what we want to do is add a bottom border to those 6 cells. In order to add a bottom border to those 6 cells, you just go ahead and highlight those 6 cells. You come up to the fonts group, select that bottom border option, and that'll put it right back. Some other things we might want to do. We might want to italicize our variable names. You don't necessarily have to do this, but it can make that a little bit clearer looking in our table. One thing we might want to do, though, so as we're looking at these values in our table, we've got quite a lot of variability in terms of the number of decimal places displayed. So some of these numbers have no decimal places displayed. Other ones, like this one here, has 5 decimal places displayed. So what we'd probably want to do is come up with a number of decimal places that we want to have as the standard and have all of our cells display that many decimals. To do that, we're going to use format cells to execute that command there. So what we want to do is highlight all the cells to which this is going to apply, which is all of the data in our table. We can then right-click, choose Format Cells from that pop-up menu. And then from there, we want to go with this number option from the Number tab. By default, it wants to go ahead and show 2 decimal places. As far as we're concerned, that's completely fine. 2 decimal places is great. And that also allows us to see, kind of differentiate visually the larger numbers from the smaller numbers because they're all right justified as well. But now our table looks pretty uniform. It's much better. It's cleaner than it was before. And we could copy and paste this table directly out of Excel and into a research paper that we were working on, and it would be ready to go as far as APA style goes. Some other particulars about APA style: we want to number all of our tables beginning with the first table through the last, starting with table 1, followed by a period, and then the table title itself in italics. Descriptive statistics is not necessarily the most descriptive title we can come up with. We could type descriptive statistics for age in months, age in years, or something like that. Or we could type descriptive statistics for key variables, and that would be a good enough title there. In APA style, the only guidelines as far as borders go is that you're not allowed to have any vertical lines in your table, only horizontal lines, and we want to minimize the number of horizontal lines. So we might put horizontal lines around the bar at the top that tells us what each column in our table is containing. And then we want an additional line at the bottom of the table to show that that's the end of that thing. And that's probably all the lines we need in this table. All right, so like I said, a lot of times I don't go off the PowerPoints, but all the information that I discuss is going to be contained somewhere within those PowerPoints. And so what I wanted to talk about quickly before we close is a few key points that I wanted to make sure you guys come away with. So what should every formula in Excel begin with? The answer, of course, is an equal sign. Every formula that you ever create in Excel should begin with an equal sign. What are two ways of creating formulas in Excel? You can either create formulas in the formula bar itself or within the cell that you're working in. What is the cell range? That defines the first and last cell that you want a function applied to. So we use the sum function today. We use the mean function. The cell range was the range across which we wanted to apply that function. We can create a cell range in two ways. I actually showed you three. So one that I did, or rather, no, that wasn't a cell range. So I showed you two of those. One is by typing in the first and last cell address of that cell range. The other is just to type the equals function, open parentheses, and then click and drag to define your cell range. So those are the two ways that we talked about defining a cell range. What happens if you copy a cell that contains a formula? Well, Excel is not going to copy the value that's displayed in the cell. Rather, it's going to copy the formula that you use to compute that value. And so when you go to paste into a different cell, it's going to paste the formula, not the value. That's going to be useful to us as we move forward here in Excel. So that completes our Intro to Excel lecture for today. We're going to have two more lectures on Excel that I'm going to record. And we're in the next lecture, we're going to be talking about some descriptive statistics. We're going to get into calculating things like variances, covariances, and so on. And then finally, in the third lecture, we're going to talk about doing single variable regression in Excel. Shortly, I'll be posting the homework assignment associated with Excel. As soon as you have that completed, you're welcome to turn it in. It will be due on the day that we have exam 1. However, if you'd like feedback on that assignment, and I'll repeat this later, but if you'd like feedback on that assignment before the exam, what I'd like you to do is go ahead and turn that assignment in a day early. That way that gives me and our TA some time to get those graded and get you feedback before the exam, because the exams in this class are all going to be open book, open note, and so you'll have that as a resource. All right, so see you guys next time.